AOS was created to provide a means for technically untrained individuals to create custom software applications for personal and organizational use. AOS is a universal solution for doing informational work because it provides access to all the data types and functions that all educated persons are familiar with. It allows the user to calculate anything possible in expressions. It interfaces to today's informational mediums such as databases and web pages. It allows any two AOS applications to work together through services, and it provides an environment where multiple users in AOS machines can share data and services and work on common processes. This video covers AOS collaborative and user applications, the reason we came to the party. There are 7 types of programmatic environments in AOS. The root environment, which is the first interface, user applications, which facilitate informational work, workspaces, which functionally combine programs, user applications, and services, processes, which manage process task completions, process tasks, which complete processes, public libraries, which provide a safe programmatic interface to trusted external entities, and task functions for doing programmatic things and expressions. We use the term task to refer to an application that partially completes another application. A process is what we call in AOS a collaborative application, where multiple users in AOS machines can participate in an AOS application's completion, or an application can be completed in parts over time. A business process is a collaborative application. Multiple users all working on computers running various applications to get work done and recording the results for processes that are repeated often with the same procedure, just like a computer program. The business processes are what the business does to obtain a return. Workspaces are applications that are usually topic-specific and contain programs and user applications. Workspaces are not considered applications, even though they are, but rather a place to combine programs and user applications for a general topic. For instance, I may have a financial workspace with various user applications, each able to do something financially specific and be able to work together. Workspaces are designed to facilitate remote use and content management with their source AOS machine. A user application inside a workspace would be called a user task of the workspace. User applications are single-user software tools that we are all familiar with, like Photoshop. They are independent tools and provide an environment for programs and 3 types of user application tasks: auto tasks, dialogue tasks, and user tasks. Dialogue tasks are used in applications to inform the user or get information from the user, or both, in an uninterrupted manner. When a dialogue task is running, no other operations can be performed by the user until the dialogue task is completed. Auto tasks stay built and ready to complete their program without user interaction at a designated time or state of the application. An auto task executes more rapidly and has only one program that executes when the Task Start button is automatically pressed, and completes when the Task Complete button expression evaluates or is manually pressed. So to keep our terminology straight when talking about programming, the official hierarchy of software terms in AOS is: processes are completed by applications. Applications use tasks and programs to do work. Tasks are completed by the user and/or programs and might contain subtasks. Programs are sequences of expressions. Expressions are sequences of functions used to evaluate pieces of information. Functions use data to complete, and data is information stored in a computer. The term processing is used whenever the computer evaluates one or more pieces of information. When the user changes a piece of information in the computer, that is entry. When the computer changes the same piece of information, that is processing. The computer does nothing but update the stored value of pieces of information it currently holds in its memory. We will begin our discussion about applications by looking at user applications because process tasks are extended user applications specifically for a process. Process tasks outside of a process look and operate like user applications. A user application begins its life as a control that is added to a program environment interface with the control selector. User applications are opened for editing with the spacebar or opened for operation by double-clicking, like all executable files. When a user application is opened for operation, its header settings assembly is hidden and the Task Start button is automatically pressed. When opened for editing, the opposite of these occurs and the user application is still active, but Task Start must be pressed by the user if used to start a program. As mentioned, a user application can be three types of applications based on settings. With visibility settings, you can place the application form, hide the form, and select the form. Since user application and process tasks use forms to do work, the Place rectangle places the form and not the control, which can be hidden if programmatically opened. This is true for other controls that have a Place rectangle driver value and use a form to do work. With status settings, you can enter an application description to be read when F1 is pressed and view the time log for application usage. User applications and process tasks, when active, keep track of time for measuring application usage. The active log is where these measurements are kept. The active log can be cleared manually or programmatically at any time. Non-instanced process task active logs can only be cleared. The content settings have just one value: the layout assembly for the application's interface controls. All active environments have the ability to store or apply the interface settings for every control on the interface. Like all values with names that don't start with a question mark, layout can be expressed to apply one of a set of layouts programmatically. The metrics collection has just one metric for tracking the user application or process task active time as mentioned. Custom metrics can be added to the metrics collection and processed as needed. The options settings allow us to set up the kind of application we want and how it appears when open. Is User Dialog makes the application behave like any dialog window. Dialogs are needed to inform or get information from the user before anything further can be done. When a dialog task is open, nothing else will respond to user actions until the dialog is closed. Hide Header hides the editor header when the application is active, as opposed to being edited, where it is always visible. Normally, applications collapse their assembly into a single value and store it in the task assembly value when closed. Keep on Tree causes the application to stay built and ready to execute, which drastically speeds up the application's response time. In this mode, the application is called an auto task and may or may not be visible during execution based on open on start and close on end settings. Timeout seconds forces an active application to close its form after a specified period, but does not affect any other settings. Column panel and row panel driver values panelize the interface, and no scroll bars hides the scroll bars on a non-panelized display. The art assembly, which comes empty, is used to hold a form art assembly if a custom design is desired. You can fill an art assembly by replacing it with one of the system art assemblies and making the desired modifications. If the art assembly is empty, form art is retrieved from the system art assemblies. The Program Explorer shows us all the expression sequences in an application, as well as any incorrect addresses, which most of the time prevents a program from running correctly. Sometimes the user will want some data from a location that is not always present. In this case, when the source is not present, the Program Explorer still reports the missing address, but the programmer knows nothing is broken. Whenever an active environment has a missing address, a red dot will appear in the upper left corner of the application's form. Suspend programs stops the application from processing data updates, which is how programs are executed, while resume programs returns the system to normal active operation. Task start and task complete are used for programming. Task start is pressed when an application is opened for execution, and task complete can be used to do something automatic when the application is done, like closing the form or starting something else. The task assembly value for an application can be expressed, which is how we make applications open programmatically. Workspaces, user applications, and process tasks all use their task assembly value to store in when not open. In most cases, task assembly will be hidden by the user when not being programmed. Everything else in a user application, workspace, or process task is whatever the programmer needs it to be. Now, let's talk about AOS collaborative applications, which are also called processes. I have a generic business process designed as an example called test process. This test process is kept in the processes collection where it can be seen by all AOS machines on the AOS tree. The databases, processes, services, and workspaces collections in the AOS machine header are the only tree nodes that are visible to other AOS machines on a networked AOS tree. Processes can also be private and used on only one AOS machine. An AOS process is a sequence of user applications made for a process called process tasks that are completed by more than one user or completed over time. The sequencing is accomplished by the use of one simple universal rule. No task can start without the information it needs. Process tasks have task inputs and task outputs, which are AOS input-output controls that enable the implementation of the one rule for processes. Processes have a process home, which is the one AOS machine that they are hosted on, where all files that support the process are kept. The address of a process home is written to all process tasks in a process and cannot be edited, as well as a unique instance ID when a new process instance is started. All processes have one or more initial tasks that starts a new instance of the process. When a new instance of a process is created, an instance folder is made and the current state of the process is stored. All the process tasks within a new instance are marked with a unique ID and a waiting status except for the process task that started the instance, which is marked completed. The current status of all process tasks in an incomplete process instance is stored in a process task status table that is readily available for review. Process tasks, when completed, are returned to the process where the task outputs information they carry is available to the rest of the incomplete process tasks. When a process task returns to its process, the process executes all unfilled task inputs and marks as published any process task whose task inputs fill in this procedure. Therefore, for a process to complete all process tasks, at least one process task must get published every time a completed process task returns to its process. When a process instance is completed, it is removed from the status table but available for review if kept in the process instances folder of the process. The process instance folder holds a historical record of every change made to a process instance and its resources, and all instance IDs in the folder can be retrieved from the process instances list in the Settings Content Assembly. Incomplete process instances can only be removed from the status table by updating remove status table instance in that assembly. In a process, process tasks will be created in most cases by the person or persons that will complete them and choreographed by the person overseeing the process design. Designing the sequence of tasks in a process simply involves connecting all process task inputs to other process task outputs in a manner that produces the correct sequence given the one rule for processes. Processes are somewhat unique in that they can gracefully handle parallel, series, and stub sequence patterns all in the same process because of the one rule. Parallel paths of process tasks can converge on a single process task because that task will wait until they are all done if task inputs are retrieved from all of the parallel path and process tasks. A stub path is simply a path that does not publish another process task, like keeping someone informed of process instances. By this definition, the last process task in a process is a stub path. Connecting up a process is accomplished by adding task input result values to the task input's input-output control and setting their addressables to the addresses of task output result values of other process tasks. Once again, all task inputs must have a connection to other process task outputs for them to get published when all task inputs get filled with data. The one rule for processes dictates that all task inputs are absolutely required to complete the process task. When a process task is in a process, only the task inputs and task outputs have available addressable data because all of the process tasks are collapsed and stored in their task assembly values, leaving only the input-output controls built. Process tasks within a process design can be opened and edited. Once a process is instanced, modifications to the process are only made by completed process tasks returning, and no further manual modifications can be made. Any corrections to the execution of an instanced process must occur within a process task away from its process home. This is to protect the integrity and truthfulness of what occurred in the process for records keeping. So, the procedure for designing a process is simply to add designed process tasks that have their task inputs and task outputs defined, and connect up their task inputs in a manner that produces the sequence of process tasks desired. In a collaborative application, users participating in the application's completion will monitor the published process tasks they are responsible for. Published process tasks are in essence an inbox for one or more participating users. If the process is present on the AOS tree, process tasks automatically return to their process the moment they are completed. If the process is not present, a process task's status will read Process Task Completed. In this case, the outbox would be Process Tasks Completed but not returned, and should be stored until returned. The Task Complete button can be pressed when the process is present to return the process task to its process. The task status is set to Process Task Returned, and the process task becomes inactive. I've made a user application that works with a process so it illustrates both user and collaborative applications. The application provides all the utilities to work with a process, such as get published process tasks for completion, get instanced or designed process tasks for review, view the process status table, get a process instance for review, and see the request status for all requests to the process. This application is sophisticated in what it does by today's software standards, but was fairly simple to make in minutes with AOS Fluid programming methodology. Computing and applications like the entire information system that humans use is simple yet powerful. Every application is a solution targeted towards a specific informational task, like editing a picture. Every solution is simply an information set that keeps track of parts of the solution over time. There only exists information we have and information we want. There only exists the current values in our solution that will change over time in the operation of our solution. Information in the computer can only change in two ways. The user changes it manually, or the computer changes it. The computer can only change a piece of information if it has instructions on how to change it. These instructions are specific steps to take to arrive at a correct change. Because there is only information in what we do with it, the instructions are what information functions to apply to what information we already have in what order. There is nothing else in all of mankind's information manipulating to arrive at the answers needed. This is what expressions are. They are instructions pertaining to a specific sequence of functions to apply to specific data in our solution to obtain an accurate and up-to-date answer for any given piece of information in our solution. Most of the information we have in any solution we can think of will be dependent upon the values in other pieces of information in our solution. If dependent values change, then the values that depend on them have to change to be accurate. These sequences of expressions are programming pure and simple. The instructions we give to the computer to do modifications to our solution's information when change is needed. A program, therefore, is a single sequence of information expressions. For instance, a value changes in our solution either by the user or user proxy control. Another value depends on the first value, so its expression needs to be evaluated, and then the next, and so forth, just like dominoes. When the program is completed by the last expression evaluating, all the pieces of information that changed are current and accurate. Most applications are a set of independent programs, each doing something different when responding to change in our solution. Coding has one way of defining and lining up these expressions. AOS does the same thing differently, but it is the same thing, which is why AOS works. So when thinking about and creating software applications, it is easiest just to think about the information you need and how it is going to change over time during operation. Some of that information will be on the interface and therefore serves as an input-output mechanism to interact with the user. All information is utterly defined by purpose in our solution, information name, information type, information form, information content, information display, and how its value changes when dependent values change. The generic process interface shown here is the kind of application a user would work with if they participate in a process. The purpose of the solution is as previously mentioned. Anything else I could say about how the application works would be to discuss various parts, why they're there, and how they change. The Program Explorer displays all the independent expression sequences in the application. The generic process interface is designed around the use of 4 service clients, each using one of the 5 services that processes provide. Each of these clients trigger off of an interface button specifically for it to interact with the test process I made. The 2 main user inputs on this application are the process task name I want and the instance ID I want, so that the client can go get the process task I want. Process task names allows the selection of the process task, and published process task instance IDs allows the selection of an ID. The application is designed so that whenever current instance ID changes, the process task is retrieved automatically. When current process task name changes, a client retrieves the published IDs for that process task, and current instance ID changes so a process task is retrieved. The dependencies and therefore the sequence is defined solely by the triggers, and a dependent value is not always used in an expression's final result. In AOS, a change in information is often a confirmation that the current value is right. Aside from the primary operation of getting and completing or reviewing process tasks, the application also provides the ability to look at the status table and look at process instances. That's it. Simple yet powerful, because any business process or any other information process in the world could manage the information exchange between independent applications and pull people together into a choreographed information system. Because we don't need to see the clients or two of the buttons that are programmed, over here we have the final design in its operating mode.